Greetings, students, and welcome to week 7. This week, we continue our exploration of search engines and go a little bit beyond Google. We'll explore these essential questions. In what ways can we apply our traditional understandings of search, especially in databases, to search engines on the free web, a continuation of last week? What does the information professional need to know about search beyond Google? And we'll explore what should information professionals know about algorithmic bias. And for that, I'm going to refer to some experts via video. Let's begin with just a few more Google tricks. One really important trick, not really a trick, is the value of Google Flights. Try comparing it to some of the other flight searches as well as the individual airlines and see that it might actually have more features and be more robust in the results and the way the results are organized and the alerts that you can choose, as well as some of the filters. I find Google Flights really helpful. There are just some very convenient little gadgets that you can easily get on Google as well. If you just type in calculator, immediately a calculator appears. I find that really handy to put in a separate screen. A stopwatch is easily available, very useful for classes and for meetings. You can easily flip a coin and set a timer. And there are a whole bunch of wonderful Translate apps that you will probably explore when we look at mobile, including some from Google and Microsoft Translate. But Google has a pretty nifty translation service as part of its regular search. Translate.google.com. You can see the number of languages. It is certainly not perfect, but paste in some text and see what it can do for you. I know Google is asking for volunteers to help improve its translation service. And then you can also just, I know this is a confusing search I did, but type in any word and say what language you'd like it to translate into. And you can use the pull down menu to help you, and you can very easily get a piece of text or a word translated super easily. You can see the sunset in New Brunswick, and actually it will also give you guitar chords or help you tune your guitar. Again, there's more like time in a different city, the temperature. Define colon is extremely handy if you want definitions and you want to compare definitions from different places. And using versus, VS, period, will allow you to get a kind of semantic type comparison similar to what you might find in Wolfram Alpha, which we'll look at in a minute. Of course, you can also use the OK Google feature in mobile, or just click on the little microphone in the search box in Google and use its voice search feature. And sometimes it's so small you probably don't see it very easily. And then, of course, Google, as I mentioned in the last lecture, has loads of educational features to support you. If you're working in higher ed, as well as K-12, as well as in the general population, or for your own professional growth. I mentioned that there are places where you can easily find documents. There are portals for that sort of thing. But one interesting thing, and I don't think this is perfect, but you can get into a search of other people's Google documents if they're made public by doing a site search. And you can search for regular documents, presentations, as well as spreadsheets. I did this for myself, and it found some of my documents that were public. It didn't find the more recent ones I was hoping it would find, but then maybe I wasn't really hoping it would find them. So this week you're going to be looking at the last part of the Advanced Search MOOC, and I'm hoping it's going to get you into the finer tune elements of Google and actually have you practice in a more sophisticated way. Let's go back just a step and think about what search engines are, because we need to compare them to databases and then for next week, subject directories. So search engines use programs called spiders, robots, or crawlers to search. They locate sites and add them to their indexes for inclusion in the results. They work with these pre-assembled lists of potential results, not results necessarily assembled at the time you put your query in. And for those reasons, it may not search the entire web as it exists in the moment. And they vary in terms of how often their spiders, crawlers, or robots go back to the site and revisit it for new content. Most search engines are quiet and competitive about their algorithms. Google is one of the exceptions. It actually lets you know what it's doing partially. Um, Not all search engines include the same results, and not all search engines return results in the same ways. And I think during your explorations this week, you'll see examples of that. Let's also remember the user, as I try to remind you all the time. As we get caught up in our learning about search, we get fascinated with how do we play this game we call search, and how do we get better at it? How do we be more effective? But we also need to remember in our excitement about this that the user may just want to find. So we need to kind of find some balance. And as we think about search engines and users, we have to recognize that users may not want to think about a whole bunch of search engine choices. Just as when we brought them a stack of books, maybe they only wanted two or three and wanted help narrowing down the scope of potential sources. So we need to think and balance what is our responsibility for access, understanding, teaching, modeling, helping to evaluate, creating an interface that makes it easy for discovery, and then sometimes really just preparing deliverables. And the reference interview, the search context, all will play a role in how we relate with our users, learners, and clients in terms of search. So, in terms of those search choices, there are a whole bunch of people and places that pull together lists of search engines, and I've listed a few here for you to look at. Uh, but just remember that some of these lists are really not lists of search engines as we described and defined them earlier. Some of them really include subject directories and portals, which we're looking at next week. Again, I want you to recognize that I have, for the sake of creating a schema, I've created these divisions for us week by week, but the buckets are often leaky, and sometimes there's not really clear distinctions among these categories that we're using. So just keep that in mind. And as you do your explorations this week, let's try to stay away from the human organized directories and let's look at search engines. There's another category of search engine, which is an aggregator. And let's think about that in terms of the discovery tools that we looked at before when we were talking about our databases. As you can see in this Wikipedia definition, a meta search engine is an aggregator. It uses the other search engine's data to present results from the internet. So it is going out to a lot of the search engines that I mentioned in the last picture, at least showed, and pulling them together and organizing them in some way. So you get a response to your query in a kind of structured way, and perhaps a way that you can choose one, the other, and you'll see them as you explore this week, and you'll recognize the category of a meta search engine. And so just to be clear in terms of that division, directories and portals, which we'll look at next week, are large or smaller subject-specific collections. Sometimes they're general collections, like the Open Directory Project. The important distinction between directories, portals, and search engines are directories and portals are categorized and selected by humans, and they are designed more for browsing than for searching. Search engines are generally larger, and sometimes they will have a little bit of a directory there, but in general, human selection is not involved in a search engine, and they are designed for searching generally rather than browsing. So let's take a very brief tour of the major search engines with the understanding that in your discussion this week, you're going to take a far deeper dive. I'm just introducing some. So you may have heard of a lot of these. Ask.com, or as I think it's called now, Ask, is really a question answering service. It was founded in 1996. You may remember a Butler logo. Formerly, it was Ask Jeeves. If you look at some of the strategies, you'll see that they resemble some of the Google filters in a number of ways. You can search in categories or refine your search to local, national, world entertainment, newsy sorts of places. You can have a location in your search. You can sort by relevance or date. There are definitely, like we saw in Google, related searches, but because this is a question answering search, it searches the questions that other users have already posed and answered. And I used Dan Russell's example, why is chloral bleaching happening? And you can see the format in the results is a little different. In addition to the general results, you get Q&A results. And in your related searches, you also get related questions. It's interesting to note that Ask has also brought in Ask FM, which is a popular user-generated question answering search, and it's been kind of controversial. I would take a look at it if I were you and see what you think of that and the kind of combination with Ask, with the general Ask site. Bing is currently the second most popular search. It was launched in 2009. It's owned and operated by Microsoft and offers, again, like Google, a variety of search services, including web, video, image, and map search. If you are an Office user, you'll notice that it's heavily embedded in your daily workflow. And just like Google has the knowledge graph, Bing has a semantic feature called its Explore panel. And then next we've got Yahoo. Yahoo was founded in 1994 by Jerry Yang and David Filo. It is now run by former Google exec Marissa Mayer. Yahoo was largely known for its huge and very popular directory, which died several years ago. I imagine that it was incredibly hard to keep up in a human way. In 2014, Yahoo partnered with Yelp and boosted its local results as a result. It had been using Google search, but rumors have it that it is using other searches like Google. It has the ability to toggle its safe search on and off. Suspect that's Google's safe search. Again, you can search in a variety of different areas. There is the autocomplete or the search suggestions as you search. There's a lot of features, and there is a very effective image search in Google, in Yahoo, probably in all of these search tools, especially I forgot to mention Bing. One of my personal favorites is Wolfram Alpha, which is completely different from everything else. It was launched by Wolfram Research in 2009. It calls itself a computational knowledge engine or an answer engine. It computes answers directly on the fly by using its data and some of the reference sources on the web. It returns results not as documents, but as data, graphs, charts, and maps. And it's truly fascinating. The results are computed dynamically, and it does linguistic analysis. It has algorithms for more than 1,000 different domains. It has 10 plus trillion pieces of data from primary sources, which it's continually updating. It has a computed type of presentation, and it has more than 5,000 types of visual and tabular output. I highly recommend you take a look at this. And if any of your clients' students are doing comparisons or working with data or need to chart something, This is an exceptional tool. You can even use it to compare calories in two different yogurts. So really just take a good look at this one. You can see what happened for fun on the day you were born. It's kind of a Swiss Army knife of data. And then finally, in our major search tools, we've got Yippee, which I knew first as Clusty, and it was also called Vivissimo. The company behind it is Vivissimo. It is a family-friendly search. It allows you to switch for optimized use between your PC, tablet, and mobile. It allows you to filter results from an index or from HighBeam, which is, I believe, a subscription service. I've seen it used at high schools. You can see some interesting filters there for where it's searching, and that you can narrow your results by domain or suffix to .coms, .orgs, .edus, and other types of URLs. What's most important in Yippee is that it is a clustering meta search. And so we talked about meta searches, but also we didn't mention clustering results. And somehow these results are organized by categories, which also suggests if you don't have a real background in the content knowledge, these categories can be very meaningful in better understanding or creating a schema around the knowledge. And it also promotes an understanding of vocabulary, and it also may suggest directions if you're beginning research. Hey, I hadn't thought about this as a direction my search can go in, but I really, in terms of chloral bleaching, I really just want government efforts, or I just want I really don't know much about chloral bleaching, but you get the idea. Clustering can be a very effective way to view results. So, what does all this mean for us? As a search professional, we need to realize that there is more than one place to start. We talked about this as we talked about our databases, whether we start with discovery or whether we start with an individual database that we know is going to meet the user's needs. Same thing happens on the free web. When we're searching free search engines, there are some search engines that are going to do different types of work and return results in different ways to meet different users' needs. And so sometimes you'll need a visualization of search, like the clustering search engines. And this, what you're seeing in this example, is Carrot. Sometimes you need to just go right into a variety of Creative Commons searches through this Creative Commons meta search. Sometimes you'll need data, and a patron will be very grateful for discovering there's a bunch of different search engines that are computational, including, of course, Wolfram Alpha. So it's important for you to have that kind of agility, and for particular clients, as you're building LibGuides and websites, to understand their needs and to suggest search tools and even embed these search boxes directly on whatever guides you're creating. Also, a growing number of people are rightly concerned with privacy during search. Do you want your search engine to collect data about you? That personalization feature can be very useful in terms of meeting your needs, but it also obscures an awful lot of the web from you. And it also means that the web is, or your search engine is, getting to know a lot about you. That could be good, that could be bad. Do you want Google knowing where you're going on vacation, where you're located right now? Do you want it to know what you bought last week? Do you want Amazon to continue to remember that? Do you want it to know what you like to eat? All of these things are decisions that you make when you log into a search tool. Now, there's a bunch of search engines to a variety of different degrees offer you safer search. Now, they're not all the same, and I wrote a blog post on that a little while back, and it might be a good idea to take a look at some of these options and share them with your patrons and users as you offer them advice. And here's a list of some of the icons for some of the ones I discovered, including one for children. And speaking about search engines for younger people, I hope this week you'll get a chance to look on our playlist if you're going to be working in youth services for some of these search tools, and they'll be growing as I discover more. And please remember, you can suggest some if you like. Now, these are interesting because in most cases, these are actually Google custom searches. Somebody has gone through the web, created a Google Safe Search, and has actually found the search, the results that are work best for students' assignments, or perhaps the ones that are really aimed at children, and just pop them into a large Google custom search. And you can do the same thing if you're working with children. But I do want you to be aware that these are not full search engines. They are search engines that have been selected for the most part by people creating a Google custom search. Let's move from those search engines, which you are going to be looking at in your discussion, to something that people are talking about a lot recently called the semantic web. And so the semantic web is different from a traditional search because in traditional search, you're looking at matching, and your search result list returns matching items. To some degree, I'm going to have you think about which of the tools I talked about earlier look at semantic search. But semantic search places your query in context. It analyzes terms and it matches terms against precompiled pools of knowledge to obtain meaningful answers. The goal is to have computers better understand us so we can get the things we need in context. So the semantic web describes the tools meant to link data and people in the web, in contrast to the traditional search methods like Boolean logic and algorithms, popularity, or matching words via text strings. Another definition is it is a data searching technique in which a query aims not only to find keywords or matches, but to determine the intent and the contextual meaning of words that the patron or person is using. So it tries to understand the meaning or the natural language of keywords better and places them in context. And it uses collective intelligence, which we'll look at in a moment. Just a little bit background on that. Tim Berners-Lee, who is credited, of course, as the inventor of the World Wide Web, has said that the web of data, or the implementation of linked data concepts on the web, was always implicit. He wrote a groundbreaking article for Scientific American in 2001 with some colleagues and imagined a world where intelligent agents would access information in order to undertake tasks and plan for their owners. In 2006, Dan Zambonini described the semantic web as the next evolution of the web, connecting data. So if you think about this progression, he said that with Web 1.0, we were connecting documents. With Web 2.0, we were connecting people. And he didn't exactly say that the semantic web was Web 3.0, but he contended that the semantic web was a web connecting data, and that term had not caught on either. So let's take a look. So if we look at the web of documents in Web 1.0 and we look at the web of data, this is the difference essentially. So when we talk about linking data, we have to understand that the links that we see on the web have specific meanings, and we're trying to make semantic relationships, and computers can't read them, so they need structured sets of information and rules of inference to conduct this kind of reasoning. The W3C consortium is beginning and has actually already developed standards and definitions for these activities. Linked data is a data model designed and published for the purpose of the semantic web. It identifies, describes, links, and relates structured data elements on the web based on these new semantic web frameworks. Schema.org, we'll see a picture of that in a sec, is a vocabulary designed to implement HTML semantic markup for web pages. It's a universally supported vocabulary extension by Google and Microsoft for markup languages. And this is what their website looks like, and it might be a good idea to take a look, dig deep into this, and see who is playing around on schema.org. If you look under the hood of semantic search, you can see, and more is going to be in that video, that it is based on the notion of triples. A basic technology called RDF describes triples, or the connections and properties or values of a piece of data. Semantic web technologies also use WOL, also known as OWL, as a consistent standard. And you can see here that in this example, this is just one piece of data. Paul Schuster was born in Dresden, and this is analyzed and annotated, and it connects this person with this place in the form of what people call a graph that is a triple, and this is RDFA. And you can see what the code looks like, and this is how it looks diagrammed. So I know you may not necessarily get deeply involved in the under the hood stuff of semantic search. I never really have, but I want you to understand what's happening. The benefits. So the benefits of a search like this are that it does not focus merely on keywords and phrases, but on entities and the way they are related. It tries to overcome language ambiguity. It provides information about relationships between entities, and it may facilitate unexpected discoveries. And in an example coming up, you'll see that. Examples that you already have seen are Google's Knowledge Graph, which automatically generate this little fun facts box. In this example, about Bill Gates and the city of New Brunswick. The Knowledge Graph was introduced in 2012, and it attempts to understand facts about people, places, and things and how they're connected. Sometimes you'll get some goofiness that it will think you want when you really want something else, but it is trying hard to understand you and what most people want when they search for these general topics. And it also provides opportunities to disambiguate. So, did you really want Rutgers University, or did you really want something specific in New Brunswick, which you could discover as you look in the knowledge graph? I did the same search in Bing, and you'll see that Bing also has a knowledge repository. It also has a semantic search that returns results just slightly differently. And so it chooses not only, and you saw in the Google example, quotes were chosen, but here we also have it pulled up Bill Gates's TED Talks. It pulled up a few different ideas for New Brunswick as well. Some of it's the same. It looks like all of it is pulling from Wikipedia. And sometimes just note that this information is not always accurate, and some of the connections are sometimes a little goofy. So just keep that stuff in mind as you look at semantic search and as it evolves. One of the exciting things about semantic search are the experiments that are going on. This is one example. It's the LinkJazz project, and it's linkjazz.org. It's a visualization tool based on linked data for the jazz world. So if you click on any individual once you go into the search, then you can see the relationships. It works by loading these triples, which we saw in the example of the gentleman who lived in Dresden. And it begins to see connections, properties, principles, values of data among the community of jazz musicians. And it visualizes the connections, who's inspired by whom, what types of music do they play. And you can see in the graph in the center that you can hover over any of these musicians, and you can see the lines mean these relationships, and they're based on triples. So if you're interested in music or just interested in linked data or semantic search, take a look at the LinkJazz project. This is just another look behind the scenes. One of the gentlemen who's involved in LinkJazz uh, shows you how these relationships are created, and you can see the HTML behind it in the relationships. So LJ, I believe, is LinkJazz, : and then you see these people played together, toured with, in a band with, band leader of, band member of. And so that's the conceptual model under the hood of the LinkJazz project. Let's shift gears just a little bit. We'll also look this week at how search engine result lists can be constructed based on algorithms that also lead to or point to algorithmic bias. Algorithms are really just math and code, but they rely on people and how people use our data. And real life biases that these people have can be carried over into these artificial intelligence systems that include our search engine results, but can be that can be insidious, but even more insidious. They also filter into the auto completion searches that we do in our typical Google search engine search boxes. You can see lots of people talking about this today. If you search for the notion of bride, for instance, this Nature article shows that we're only seeing Western pictures of brides, and in our image results, we're not seeing, for instance, South Asian representations of brides. It can be even more insidious and racist. It can algorithmic bias can influence election results. We're going to be referring to Dr. Safiya Noble's Algorithms of Oppression. You'll have an opportunity to watch one of her speeches or another lecture on algorithmic bias. And I hope that we have a rich discussion on this big issue in our discussion forum in Canvas. And we'll also have an opportunity to dig in a little deeper on our playlist about algorithms and biases. This week, you'll be engaging in an activity that will it require your response as well in our forum or online or in class discussion. And this is our search engine teach back. I can't teach you about every search engine there is out there, but I want you to make these discoveries. So on the second slide of this slide deck, you'll see a number of suggestions. You are welcome to dig a little deeper in some of the ones I did introduce, but I want you to take a slide or two and really tell us why we should or should not use a particular other search engine other than Google. Tell us about the affordances and constraints. Tell us about special features. Really take a little bit of a dive into it. Do some test searches and let us know what you discover. You are responsible for making sure that everybody in the class knows about the search engine that you select.